Well, it would be good practice to go through a bunch of the other amino acids too, but since our time is short, maybe we'll move on to something else. But it would be good practice for you to try to go through and draw the correct structure for all these amino acids. And I don't know how you can check yourself, but hopefully you try to check yourself to make sure you're drawing those correctly. Let me just warn you about the weirdest amino acid of all, which is proline. So I'm not going to try to make you do that from the table. I'm just going to show you what proline looks like. Now, in a sense, proline is very simple because the side chain is just 3 carbons. So let's draw the side chain. 1, 2, and 3. Proline just has a 3-carbon side chain. So far, very simple. The complication is that the number 3 carbon on the side chain forms a ring with the main chain nitrogen. This is something we haven't seen on any of the other amino acids. So this is unique. Normally the main chain nitrogen has nothing to do with the side chain. Normally the side chain is completely separate from the main chain nitrogen. This is the only case where the main chain nitrogen forms a ring with the side chain. So we just have to learn this separately. And now, this nitrogen now should only have 1 hydrogen if it's going to be in its neutral form. It says it has an extra bond to carbon, it should have 1 fewer bond to hydrogen if it's going to be in neutral form. Now, how would you look this up in your chart? Well, the key thing is to notice that in the chart, they didn't draw the side chain, they drew the entire amino acid. This is the one case where this does not represent the side chain, it represents the entire amino acid. Point to the alpha carbon. Right, and point to the first carbon in the side chain. Now careful, the side chain is attached to the alpha carbon, right? Maybe that was an ambiguous question, but who's the first carbon in the side chain? It's the first carbon that's attached to the alpha carbon. So which one is that?
It's this one.
Yeah, this is not the side chain, this is the carboxy carbon, right? Remember that COOH is a common way to write carboxy. So this is the first carbon. Now point to the second carbon in the side chain, then the third carbon, and as we've been promising, the third carbon loops around and forms a cycle with the main chain nitrogen. So this picture is exactly the picture that I have on the board. Okay, so you have to keep in mind that you don't need to have the proline memorized because theoretically you can look it up in the table, but for proline, they don't just show you the side chain, they show the entire amino acid, whereas for everyone else, they just show you the side chain. But it's really a very simple situation. You draw a normal amino acid as if there was 3 carbon side chain. And then you have the third carbon loop around and attach to the nitrogen, and this nitrogen should have 1 fewer hydrogen than normal because that's an extra carbon bond. Okay. Let's draw tyrosine. Give a number to. Start by giving a number to this carbon. You don't need to do that. You can just, since you already have a 1, right? Just call that, I don't know, 7. That's fine. Now, which of these carbons should be attached to the alpha carbon? Which number? first of all, you know that because it's furthest to the left, and they usually try to put the carbon furthest to the left as the one that's attached to the alpha. But also you can see it only has 3 bonds so far. So it's got to be the one that's attached to the alpha carbon. So it looks like here's the side chain they give us for tyrosine, and it looks like when you originally drew this, you drew it like this, but that misses the point that this carbon is in between the ring and the alpha carbon. We should always label the alpha carbon. First we need to put in the CH2 group, and only then can we put in the ring. It's not necessary here to be too punctilious about where the double bonds go because this is benzene. Remember that benzene has 2 different resonance structures. In fact, it's simplest just to draw it like this to show that the double bonds are always moving. You got to put the OH directly opposite the CH2 group. So you really have to take our time when we're drawing this. By the way, this is something you're pretty sure to see on the test. He likes to give you problems where he just says, draw tyrosine, or draw aspartic acid. So you definitely want to take the time to practice drawing these. Again, if we had more time, we would go through all of these together, but unfortunately we won't have time to do more of these, but it's important that you try to practice these on your own, and if you can, find correct pictures of all of them so you can check yourself to make sure that you're doing them correctly. But we'll try to squeeze a little bit more in today.